All right, let's switch gears a little bit and talk about Kirchhoffs laws. The Kirchhoffs laws are one of the three foundational laws. We've got Ohm's law, and there's some equations that we use to define circuit elements, but current law and voltage law, those are the things that are going to, are really the baseline of all of our circuit analysis. Kirchhoff's current law, we've talked a little bit about this idea already, but if we have a current coming into a node, any current coming in has to leave, right? So the sum of all currents has to be 0. We can't generate current, and we can't have current disappear. If it comes in, it's got to go out. Now, the positive current is totally arbitrary. Excuse me. It's totally arbitrary. In this class, we're going to use positive as flowing away. So output is positive, input is negative, right? This is not too different from PSC, right? Absorption is positive, so flowing away is going to be positive. Voltage law, on the other hand, is about voltage, and we're talking about anytime we go around in the loop, that's a complete, almost like, you can think of it as a complete circuit, right? Going around the loop, we're going to have a voltage drop of 0, which is really helpful because oftentimes we can use this in more complicated circuits. The choice of the way that you decide your loop and your sign convention is totally arbitrary, but with a big old but here. We want to go clockwise. That's going to help us as we solve these problems together in class. And we want to follow that passive sign convention, right? We're going to assume voltage drop is as positive as in the PSC. So as we go across this, as we go through this way, that's against voltage drop, that's going to be negative 12 volts. This is against voltage drop, that's negative V2. Going across from positive to negative is a positive voltage drop, so that's positive V8. And as we go around this way, we'll start here at the top. That's usually, that's where I like to start. We'll do a voltage drop from negative to positive, which is negative. We go from positive to negative, that's a positive voltage drop of V4. And then we have our voltage source Vs here, and we'll define that as positive to negative, so that is a positive voltage drop. All right, so let's do an example, right? For this particular one, we're looking at a KCL example. We want to write down a KCL for each node.